So I think there was lots of questions around this in the press, popularized as the golden key. So we just wanted to cover it with you guys because it was portrayed as relating to secure boot, and really it doesn't really relate to secure boot. It relates to debug policies we had for allowing people to run arbitrary things or attach debuggers to the Windows operating system when it boots up. So yeah, it's not an issue with secure boot. There was no actual keys leaked, no private keys or symmetric keys or anything like that. And there was no, for Windows customers, there's no impact on sort of BitLocker or disk encryption or any other capabilities of Windows to do with, say, TPM. Background is we had, for Windows RT, for those who remember that, it was a lockdown platform, so you couldn't run arbitrary code, but people who are developing code on that need a way to develop. And so rather than having special hardware, we had the ability to unlock devices on a per-device basis. So you'd get an unlock package that would allow you for that particular device to run your arbitrary code or connect your debugger. Then in the subsequent version of Windows, we changed the mechanism for how these debug policies work and how they were associated with a particular machine. And unfortunately, there was a design flaw where you could use these new style policies with older versions of Windows without having them unique to that particular Windows device. There's still some limitations around how you actually get that policy installed on the device, which is why you need administrative access or physical access to the machine. So it's not sort of a super widespread attack. And it doesn't apply to, if you have the latest version of Windows or now, at some point the patch version of Windows, you don't have any, we still have the ability to target them to individual machines, even with the new style policies. So really it's about using this new style policy that we had shipping out with the HoloLens development kit on older versions of Windows to unlock it so that you could run arbitrary code or hook up a debugger, which on certain platforms you wouldn't normally be able to do, or with secure boot enabled, we by default don't let you do in Windows. So what's next? The OEMs, IBV, should continue to build and ship Windows devices as before, no particular changes. We have updated the DBX, we revoked some of the image hashes of particular boot managers. So you should use that latest DBX update. But if you do run into issues, we have an errata until October of 2016 around matching the proper DBX. So it shouldn't impact shipping, but by October, November, make sure that you've got the latest DBX and are shipping by default with that.
Hi, I'm Suhas, Manangi, Program Manager with Microsoft, and I work for OS Security team. I mainly do work on Windows hardware, compatibility requirements, UEFI secure boot, little bit of device guard and device guard requirements and things around that. The first one is basically changes in the Windows hardware compatibility requirements. This word keeps changing every release. Let's go with WHCR. Mainly two bullets. First one, the memory requirements, NVRAM memory requirements, which was earlier half of this. We are doing a lot of work using UEFI boot service variables or runtime variables, basically these variables. And we don't have a shortage of the space just yet, but soon we will hit that space. So this is a preventive measure so that we can get more space right away in the hardware now than dealing with it later. So do let me know if you guys have any concerns with this increased size requirement for NVRAM or just the reserved memory for UEFI variables, and we can talk to it. So it's basically 128 KB, 64 KB reserved for the 64 KB and 64 KB for both authenticated and unauthenticated, and boot service as well as runtime variables. The second bullet is basically a new requirement for confidential and relay protected storage. You would hear about the same thing in TPM as well. Although this is not a requirement right away, we are putting it as a recommended so that ecosystem starts moving towards that. And later some stage where we have buy-off from most of the ecosystem, we would make it a requirement. But at least till end of 2018, it won't be a requirement, and we can figure out where the ecosystem is in 2018 and then move accordingly. We want the ecosystem to get there as soon as it can. There's one more change in the vehicle signing requirements for kernel drivers. This won't impact any of the UEFI drivers or UEFI driver submitters. It's just the kernel drivers. But many of you might be writing kernel drivers. Starting basically starting October, all drivers must be vehicle signed, or if you have a cross-sign certificate issued before July last year, you'll be able to use that as well. So in addition to that requirement, there's one more requirement basically where you need to have file version info and file information in the driver, so that we'll be able to, device guard will be able to make use of that, as well as the OS as well. And all kernel drivers needs to be HVCI compatible as well. That was about for the WHCR. For device guard, we have device guard readiness tool. The version 2 of it should be released in a week or two, but the links for this is towards the end of the slides. You can use device guard readiness tool for verifying whether your device is capable for device guard, enable, disable, integrate with SCM, and few things like that. Do check it out, try it out, and let us know if you guys need any more help understanding the output or usage of the tool. For DG OEM requirements for TH1 and TH2, we did have quite a few concerns last time when we were talking about RS1 requirements for device guard. There was nothing mapping for TH1 and TH2. Sorry, for folks who don't know about TH1, TH2, it's basically the internal usage words we use for 1507 Windows, 1511 Windows, and 1607 Windows. TH1 is basically 1507 Windows. So we do have DG requirements for PC OEMs published on MSDN. It got published about a month and a half ago. Again, links for those are towards the end of the slides. Let me know if you guys need more information on that, and I'll be here and we can chat about that. What's new for RS1 and RS2? We have been discussing about secure NX protections and SMM protections within USSD and other security forums. So all three are now requirements for RS1 and RS2. Firmware updates to ship through Windows updates. This keeps coming up again and again, mainly for the server-related implementations. Desktops and client system typically never had proprietary solutions for auto updates of firmware, and that's where we are mainly pushing Windows updates as a mechanism or as a pipeline for firmware updates to go through. That way, customers can always get the quickest and the fastest way of firmware update whenever new security patch is available or aggressively patched vulnerability is found. For servers, if you guys already have an alternative way for automatically updating firmware, then we can discuss about that, and as long as it is automated and user doesn't have to take actions, we should be okay with that. But again, it's through exceptions and contingencies we can talk about it, discuss, and then agree upon one thing. But for desktop, we absolutely need Windows updates as a mechanism for firmware updates. For servers, we can discuss and agree on something depending on what you already have. The next one is UEFI with device guard. This again comes up about needing UEFI, Microsoft UEFI with device guard, and how ecosystem has already taken a dependency on that, and why we are trying to move the ecosystem in that direction. Basically, DG requirements requires Microsoft UEFI to be removed This does bring in few concerns, but before we get there, the context for that is Device Guard basically provides full control for enterprises or customers to configure what is approved or allowed or configured to run on the device. And if you include Microsoft UFCA, it basically allows everything that we have signed in by Microsoft UFCA for last 5-6 years. So that kind of opens up the box for all sorts of things. And one of the main goals of Device Guard is to provide ability for enterprises to configure what the whole thing that runs from power on till user mode, or including user mode. So that's the reason we have a requirement to remove Microsoft UFCA right out of the box. But if enterprises chooses to keep it, well, it's their requirement. Well, when we ask OEMs and IHVs not to take a dependency on Microsoft UFCA for Device Guard, we often get asked what are the alternative options, and these are the 4 options we have come up with in a decreasing order priority, or first to last. First is what we prefer, and you can go down the line. The first one is system firmware. Bake everything you need into the system firmware. That way you don't need a certificate in DB to trust what is needed to boot and for the functioning of the device. Sure, if customers or enterprises want to install a third party or after manufacturing or aftermarket products, they'll be able to do that either by signing themselves or including IHV certificate. We'll get to that part. The second one is OEM UFCA. This is the closest that would map to Microsoft UFCA. OEMs who are offering Device Guard compatible and ready devices, the recommendation is for them to set up a CA and sign what they need for their OEM devices to function end to end. And a few of the recommendations that are put out so that you'll be able to bank on what we provide for Microsoft UFCA, be it security reviews or product reviews, and use that as your basis to approve what you want to sign. For example, your signing policy could include that the product must be first signed by Microsoft UFCA. That way it will go through all the security reviews, and you only have to re-sign it with your key without having to invest too much into tooling or security reviews or expertise. Just a suggestion, but you could as well design those policies extensively that meets your business. And a few links towards the end of the presentation that you guys can use to understand what we do and what are the signing policies and what are the tests available, etc. Third one is IHV UFCA. This is kind of slightly harder, mainly because the complexity of OEM or the product mix OEMs puts into the devices. And but again, that's an option. If IHV signs it themselves with their CA and provides their certificate to the OEMs can bake that into their hardware. But if OEM uses too many IHVs, then they'll have to include too many certificates. The complexity exists, but then that's an option. And then direct hash, that's the least preferred, mainly because the serviceability is greatly impacted. But if you have really closed system where you don't service it, or you really have closed system where you service the hashes as well, so you can go about using direct hashes into the DB. That works as well. We have 3 more signing policy updates. The third one is more of a FII than a signing policy. The first 2 is we had those first 2 up on the signing policy website for quite some time, but somehow the communication hasn't been strong on that. That's why we still keep seeing those submissions. The first one is basically a policy of not signing runtime UEFI drivers. If you're producing or if you have a dependency on needing runtime UEFI drivers, we request you to move to boot time, and you'll be able to see documentation on how to do that. Similarly, for EBC code, we support x86 or x64. We don't support Titanium, mainly because it doesn't have secure boot. Mainly to reduce the surface and even including the EBC, we don't sign EBC codes. So you can submit x86 and x64. We sign them both, all good. But yeah, we expect to see x64 or x86, but not EBC code. Having said that, a lot of submitters who already have signed up and doing this for some time, we wanted to give them a runway for them to plan it out. Although this was published kind of last year, there were still hardware cycles they wanted to support, and some of those were towards the end of life cycle. We didn't want it to cause too much churn in the ecosystem, so there is an exception for this till end of this year, only for the existing submitters. If there are any new submitters, we want them to on the good path from the beginning. So do plan for this. If you have any concerns, we can talk about it after this presentation, and we can come to some agreement. But end of this year is our exception timeline for you to move away from this. The last one is mainly around file or volume-based encryption softwares. Scott did talk about some of the revocations we did for golden key or debug key leak or file leak. One of the changes there was the way we service boot manager from offline to moving to online, where we mount up the UEFI system volume and then service it. Some of the file and volume-based encryption saw that has a new volume and encrypted the UEFI partition, thus blocking the boot. So the recommendation here is that if you're not offering full disk encryption, or if you're offering file or volume-based encryption, then we can share the code, sample code to detect the UEFI system volume. So make sure to have an exception rule to not encrypt UEFI system volume. Otherwise, you would be encrypting something that you can't decrypt, and the boot would block. Yeah, 1/1/2017 is the enforcement date for the runtime drivers and EBC. After that, we'll stop signing. Till then, we'll sign those who have already got an exception, and we won't sign any new submitters. Windows and UEFI version. Nate, who's going to talk more about enterprise deployment or customized deployment of Secure Boot, he would get more detail into the UEFI 2.5. But as of today, Windows doesn't have any feature requirements for anything more than 2.3.1c. That's been that way since Windows 8.1. So that will suffice. That's our minimum hardware requirements for UEFI. When would we move to UEFI 2.5? I don't have an answer yet. Nate will provide more details there. But there is some churn and some flux in the specification itself and the Tiana course implementation. Again, Nate will provide more information. Sorry. Yeah. So till those things are figured out, we are not planning to take OS dependency on that. But soon after that, we should be able to have OS dependencies to support UEFI 2.5 features and go from there. Similarly, we also have a requirement for HTTPS. If you guys are providing HTTP boot, either HTTP boot or platform recovery that takes a dependency on HTTP boot, we do have a requirement for that to be on a secure channel, mainly because that will open up yet another channel of bringing down untrusted or untrusted or vulnerable components and load. So we do want that to happen over a HTTPS connection. Again, there is some flux there, not a fully ready Tiana core implementation. That's why we are not expecting, or we are recommending not to use 2.5 right away till at least one of the OS vendors takes a stronger dependency on UEFI 2.5. I think.
All right. Hi, everyone. I'm Nate Nunez, another program manager on the OS security team, and I'll be talking about two upcoming features. First one's customized deployment of Secure Boot, and the second one is consistent Secure Boot workflows. So first, the customized deployment of Secure Boot feature is defined in UEFI 2.5 spec. Right now, you sort of have to manually set these Secure Boot options for PK, KK, DB, DBX, and we want to provide a way for end users and IT admins on the first boot of the device to be able to customize those options and then deploy it programmatically. This will take advantage of the new modes in UEFI 2.5, setup, user, deployed, and audit mode. And it also will be measured within the TPM, PCR7. So this feature, that's what it is. And like Suhas mentioned, there's been a little bit of ecosystem flux. We've been investigating this feature already, but because of different moving parts with things being defined properly in the TCG spec and in the UEFI spec, as well as the Tiana core implementation, we're looking at this to be more of our target for rolling out this feature. So basically, we're going to resolve the previous ambiguity regarding certain secure boot variables in the UEFI spec. We'll also be stabilizing the TCG spec, testing against Tiana core until we're ready to go with this feature. So So this is the second feature that I mentioned, the Windows consistent secure boot workflows. And this one basically put up two images here to show that the user experience of configuring these secure boot options can vary quite greatly depending on which BIOS you're using. And even the right example, the Surface Book, uses an EFI application to do this. So with this diversity in the user experience, we want to sort of move towards a more consistent one where we can look at the secure boot menus that are in the different BIOS implementations and at least provide a few consistent options that people can depend on so that they can look and know that this is some sort of option they should expect on this page to add a hash to DB or to revoke. So these things we want to sort of have a little more consistency around them, and to make sure that we do this correctly, we're having drafts of the consistent workflows document up on Connect. We've had initial feedback already, so thank you to those in this room. If any of you are here who've given feedback on that first round, we're iterating on this, and we'll have a second draft out sometime in October. So we'd love to get more feedback on what you guys think about this document. And I think there will be a way to email or contact us later if you guys want to be more involved in that effort as we work towards making this sort of a requirement for the UEFI 2.5 BIOS. Yeah, that's all I have.
I'm Gabe Stocco, program manager on Windows device security team. So first thing I'm going to talk about is tree protocol. So it's a EFI protocol allowing the bootloader to communicate with the TPM, particularly for gathering measurements, passing TPM commands, etc.
You don't want me to push buttons?
What?
You don't want me to push your buttons?
No, it's fine. So recently we transitioned from the tree protocol, which was a Microsoft proprietary defined spec, to the TCG 2.0 protocol. It has the same GUID, same capability API. So basically it's very similar. The TCG adopted the tree protocol and made some minor adjustments. So moving forward, you should transition to using the TCG protocol. That will be the standard going forward. The biggest new feature is the support for crypto agile functionality. So it'll allow you to have systems where you can choose to have SHA-1 banks for legacy systems and SHA-256 PCR banks for new Windows 10 systems. So why did we transition to TCG 2 protocol? TCG adopted the tree protocol and now calls it the TCG 2.0 protocol. We wanted to bring it to an industry standard organization so we could have more input from other players in the industry. The upcoming or kind of current Windows hardware requirement is that TPM is implemented with SHA-256 banks, which mandates that you use the new TCG 2.0 protocol because the old tree 1.0 protocol does not support SHA-256 banks or crypto agile banks. This is about a hardware security test interface. So as we've seen a number of presentations at Black Hat and Revelations, testing system security is very important in the factory and manufacturing. HSTI provides a convenient interface for these self-tests. So these are tests that you probably already have, you probably already should have, and will help you ensure that systems are configured correctly. So this provides a standard interface for reporting the results of the tests. This helps Windows to identify if a system has been configured correctly, and also helps manufacturers identify if they have correctly fused all the keys down, removed test keys, etc. If you have questions about how to actually implement HSTI bits, right now the spec defines all the bits, or the spec allows the silicon vendors to define all the bits. And Intel in particular defines specific bits for IBVs and has a range of bits that you can use for your own custom purposes. Soon we will be releasing a draft of HSTI 2, which will allow some greater flexibility and add some Microsoft-defined bits that will speak to higher level features that we want to see in Windows security that are vendor neutral in terms of the implementation or how you implement that security feature can be up to you. And so we believe that HSTI is providing excellent security value to Windows customers that we previously couldn't get. This is allowing us to actually see the result of these tests that are otherwise programmatically untestable. So it's allowing the hardware to say, okay, I've been correctly configured, which is previously something we could not do from software. So Microsoft is expecting you to enable HSTI on all platforms on which is it available. Particularly right now, there are gaps on server systems. We have a new qualification called Azure AQ, which is for secure Azure stack. So basically secure host isolated VMs. And to ensure those systems are configured securely and correctly, the method we would like to use is HSTI. So we're going to be moving out HSTI into basically standard required everywhere interface. So there's a heads up that you should get on board. We're looking for ways to improve it. If you have suggestions, if you have current issues with how it's implemented, you have ideas for how to make it easier for you to use, or something that would help it make it more powerful for you, let us know. The current specification is available in this link that's going to be in the PowerPoint. You can contact me directly if you have questions about HSTI. I write the spec. Or if you need my contact information, contact any of these fellows here.
We have a call to action just to kind of bring it up to speed, basically summarizing what everyone just said. And then this is actually an alias that you can use to contact any of us. And if it doesn't go directly to these folks, let me know. I'm actually on this alias. And here's the list of links that we had. So if it does get printed out or something, it's all there. Thanks for attending, and I think we have a Q&A.
Okay, so the question was on Device Guard, which right now is just on enterprise SKU, server SKU, IoT, so it's not on sort of the pro SKUs or consumer. I think in terms of that particular feature, Device Guard basically incorporates three things. One is our virtualization-based security technology, where we have things like hypervisor protection of code integrity and Credential Guard, which protects against like the hash attacks, et cetera, by keeping that information in an isolated environment protected by Hyper-V. It also includes the configurable code integrity, which allows you to do application whitelisting or driver whitelisting or blocking. And then it includes sort of the firmware lockdown aspects, some of which Suhas was talking about earlier. So if people are creating, an ATM or something, somebody can't just go up and boot into something else in order to get it to spit out money, as in a simple example, or get into the BIOS menus and turn off secure boot or whatever else. So it's a lockdown environment. So those are three core functionalities of Device Guard. Usually when we are at the main ones that have any kind of reliance on the firmware are the first one to do with the virtualization-based security and the third one locking down the firmware. So the question was, is any of that moving sort of to a wider environment? And definitely for the virtualization-based security aspect, the long-term answer is yes. So at some point, we would like to see consumers get those same security advantages like hypervisor protection of code integrity, or virtualization-based security is also used for securing biometrics or for securing credentials like I was talking about before. So in terms of your longer-term planning over the next couple of years, I think definitely for the virtualization-based security aspects, which probably have the biggest impact on people in this room, you should plan for that being a wider spread technology, not just for particular SKUs or of the software or hardware. Right, so the question is, the biggest concern is the removal of the Microsoft CA key. So no, that would not be something that we would prescribe for consumer devices. Obviously, for consumer devices, they want to have choice to run what they want to run. So we don't want to take that away. Really, when we're talking about that requirement, we're talking about, the examples that I gave before, like a particular lockdown device where you're creating a secure administrative workstation or a secure server or an ATM or whatever it is, where you want to say, I'm only running the exact thing I want to run in this device. If you're just a consumer buying an arbitrary device, we don't know ahead of time what you want to run, so you need to leave that flexibility there. So yeah, that part wouldn't come. The one caveat to that, of course, is the stuff that Nate was just talking about, the customizable deployment options, right? So when you look at the baby duck in the future, you can imagine that depending on what the consumer decides to boot, whether it's a Linux distro or Windows or something else, that you may get, I don't quite want to say locked, but you may have that as your environment unless you go into the BIOS and reset. And that's part of the reason we also want to have the consistent BIOS menus, right? So that we can give instructions that will work on any PC to say, get into the BIOS, and then you'll have this option to reset your customized secure boot deployment or whatever.